Thank you, sir. Good morning, everybody. I'm just a small piece of Lockheed Martin Space, which I'll tell you a little bit about more in a second. So I'm really excited to be here today. It's really important for us. We're actually hanging out all day, so I'll try to leave some time for questions at the end, but if not, come find me. We're right over there. We're going to be doing a panel later and a career mingle session, so feel free to come talk to us. This is what we're here for today, because we need the next generation and the new talent. All right, so very quickly, I'll tell you a little bit about who I am and where I come from. So I'm Will Santiago, as Martin mentioned. Graduated from Embry-Riddle in 2006, and right from there I started working with Lockheed Martin on the Orion spacecraft outside of Houston, right in front of the Johnson Space Center. So my background, it's really in aerospace engineering, but at Lockheed Martin we do all sorts of careers. So I'm mostly doing now what it's considered mechanical engineering, a lot of computer modeling and analysis. So as Martin mentioned, I'm working on the Lucy mission right now, which is a mission launching in 2021. So it's currently in development here at Lockheed Martin at our Waterton campus, and we'll be launching in 2021. And the mission is going to take quite a few years to get to Jupiter because it's so far. And there we're going to be studying the Trojan asteroids that are in front and behind Jupiter, that are captured, in a stable orbit because of the sun and the orbits. So Lucy will be the first NASA mission or any mission in the history to go observe these asteroids real close. And these are believed to be the early remnants of the solar system. So by understanding those asteroids, we can learn more about the solar system formation as a whole and try to answer some of the big questions like where do we come from? Previously, I was working on the Orion spacecraft, which is NASA's next generation deep space crewed vehicle that's going to take our astronauts to the moon, Mars, and beyond. And then before that, or in between that, I also worked at the competition. I worked at Boeing for a little bit, working on the commercial crew program that's going to launch astronauts from U.S. soil back to the International Space Station and orbit. So I've been fortunate enough that I've worked in quite a few programs in my short career, and I've worked with some really, really cool people. Highlight some of the pictures there. The one that I really, really kind of want to highlight, because I don't think I'm that cool, but that's me kind of back home in Puerto Rico working on a little water bottle rocket when I was about 7 or 8. Fast forward to 2018 of last year, and the picture on the bottom is me standing near the pad in Vandenberg, California, at the launch site for InSight, for our InSight Mars lander that we built, launched, and are operating from here in our Colorado facility for our NASA Jet Propulsion customer. So fast forward a few years and it happens, and I don't like to think I'm really special or anything. I just enjoy what I do, love working with really smart people, and working on some really cool programs. A couple of other pictures there with the Orion Exploration Flight Test 1 article that we launched in 2014, that orbited a 5-hour orbit, went further than any other spacecraft since the Apollo days. From Earth, and the intent of that flight test was to understand and make sure that the systems such as propulsion, the parachute system, and the thermal protection system that we need for high-speed entries coming back from the moon because of all the heating, we're working on operating properly. Our next mission, it's planned to launch hopefully in 2020, 2021. That will be the Artemis 1 mission that will kind of study or check out the systems for life support systems. So it's going to be an uncrewed mission, and it's going to go to the moon and then come back, and eventually Artemis 2 will be the first mission that launches astronauts to the moon. So a little bit more about me. I love photography, and how can you not love hiking in Colorado? So I like to take my camera and go out there and hike quite a bit. So I take a lot of pictures of the super awesome scenery. Do a lot of STEM outreach, although it makes me extremely nervous to talk to people, on a stage. But it's important because we need that new talent, and that's really why we do this. We need the next generation of scientists and explorers, and that's what we're trying to get you excited about, because there's some really cool stuff coming that I'll tell you a little bit more about. Love traveling and watching Formula One and MotoGP. Love racing. I wish I could be a Formula One driver, but I got a pretty cool job, so it's fun. One picture I want to highlight, the one in the bottom there. So when we built this spacecraft at Lockheed Martin for NASA, One of the cool things, right, we work really hard, sometimes days, nights, weekends, you name it, to try to get this spacecraft to meet that launch window, because Mars and the orbits have to line up just right, and we got to execute and make sure the spacecraft builds. So sometimes we make a lot of sacrifices, and our families recognize that. So just before we launch, a few months, we actually get the families of the engineers and everybody working on the program, and we bring them on campus, and they get to take selfies with the spacecraft. And the one right there, it's inside up to the front that we launched in 2018, and it's currently on the surface of Mars. And it was really special because on the background right over my head, it's OSIRIS-REx, which is a mission that we launched also in 2016, that is now at asteroid Bennu, that is going to bring back the first ever NASA sample return mission for an asteroid. So you have probably heard of Hayabusa and JAXA. So the Japanese Space Agency has returned already samples from an asteroid. This will be the first asteroid sample that NASA brings back. We actually don't get that until 2023, but OSIRIS-REx is orbiting and studying the asteroid and determining where it's going to collect that sample. All right, enough about me. I'm not that cool. Let me tell you what we do.
Space is not a destination. It's not a tourist attraction or a delivery route. And we know it's not a race, because last we looked, there is no finish line. Despite what others may say, space is not a place to go. Space is a place to do. A place to do big things, important things, useful things, epic things, things that help militaries protect better, things that help humans communicate better, things that teach us about other worlds, and about how we can better protect the one we live in now. There's an asteroid up there that may reveal the secrets of the universe if we can bring home a piece of it. Let's do that. We won't need to launch satellites anymore if we can 3D print them up there. Let's do that. There are terabytes of data that must be turned into vital information. Let's do that too. Let's solve the world's biggest problems. Let's invite the bold and the brilliant to join us. Let's unleash the best engineers on and off Earth. Because doing is what we do.
All right, so you saw quite a few things in a very short amount of time of the many things that we do at Lockheed Martin. So we're a really large corporation, right? There's multiple business units. Most of us that are here today work for Lockheed Martin Space. So we are responsible for working on many different missions, including civilian customers on the defense side. And I'll touch briefly on a few of those highlights. So SBIRS, Space-Based Infrared Surveillance System, satellite for defense customers. And it's primarily there to do missile defense, missile warning, and basically also help our troops on the ground with battle awareness. State of the art, collects a lot of data and intelligence to help support our troops and our allies on the ground. And you'll notice that some of these spacecraft could look kind of similar, and that's kind of how we help reduce cost to the customer, right? Not redesigning the wheel. So the spacecraft bus and the primary architecture, they're very similar in the avionics next to each other, and it's part of our A2100 suite of advanced spacecraft. Next over, you probably have heard of this one enough. So it's GPS, Global Positioning System. So at Lockheed Martin Space here in Waterton, Colorado, we have a building completely dedicated to the assembly and the design and integration of the next generation of advanced GPS satellites for the Air Force. So there's a clean room, which is really a large building, almost like this size, that there's multiple satellites. We have like 5 or 6 at a time getting built to complete the constellation of the GPS satellites that is going to replace the earlier generation. A lot of advanced technology in there, some that we obviously cannot talk much about, but the whole intent is to make our troops safer, right? Give them more accurate information, reduce the lag of information that it takes to get the signal down to the Earth, and it's going to help not only our troops, but also the industry, right? A lot of, delivery services nowadays. So helping to kind of cut down the times and help the industry not only from shipping, but also banking, making the whole overall industry a lot more efficient, and obviously help you navigate to get to Wings Over the Rockies this morning. Next generation weather satellites. So we are also building the next generation GOES satellites. We already have 2 up there, GOES East and GOES West, that are basically observing that portion of the hemisphere. And these satellites are the next generation of GOES satellites that basically tell you all the information about weather, hurricanes, right? Looking at the continental US, the Caribbean, and the Atlantic, and the Pacific coast. And it's got some really amazing advanced technology, including this instrument called Global Lightning Mapper that can do early detection of severe storms. And it has already detected severe storms in advance enough that has allowed us to warn different states, for example, that suffer from tornadoes, and it has already saved lives. It can also detect detailed information about fires, right? If somebody needs to evacuate. And the whole intent of the satellites is to kind of advance those instruments to expand that time of warning, right? Because it's so short when a severe storm is coming, right? And we want to protect lives. So this satellite has advanced technology to help us bring that back in seconds and seconds into the past to help us warn people on the ground of threats that are coming. And humans exploration, right? We're here celebrating 50 years of Apollo. So Lockheed Martin also in 2006, 2005, got the NASA Orion contract. The Orion spacecraft is the multipurpose crew vehicle that I was telling you will take astronauts to the 2D space, right? We have the commercial crew teams that are working on launching spacecraft to low Earth orbit. Orion is NASA's spacecraft to take astronauts beyond low Earth orbit, eventually to the moon and to Mars. So Lockheed Martin is responsible for the design of this entire system in partnership with the European Space Agency for the European Service Module that has the propulsion and the solar array power and all the support equipment. And the capsule, which is the crew module, in the days of Apollo it was called the command module, that's where the astronauts will be. So it's got all the life support systems. It's quite a bit larger than Apollo, and a lot of more advanced technology to make it autonomous, because eventually we're going to need to dock to the gateway. That's going to be basically a small international or an international space station orbiting the moon. So Orion will go there, dock, and then eventually there's a lander that's going to take the astronauts back to the surface. So Orion is also designed to be expandable to support missions all the way to Mars. We're going to need more architecture and more space, right? Because the capsule is small. So the astronauts will need more space. So there's going to be more vehicles that Orion will fly to Mars and basically help us take astronauts to the surface. And then we do a lot of architecture, a lot of design to help the industry push forward, like things like the gateway, or coming up with concepts for architecture of landing on the moon. What does it take? The human landers, how many elements do we need? Descent stage, ascent stage, to get the astronauts safely to the surface. So there's a team that works on advanced programs and concepts to help move the industry forward and basically expand and get people excited in the industry to come up with the technologies that we need to get to the moon. This is the part that I know a little bit more about because I'm part of the deep space exploration team under our commercial civil space organization. So I've been fortunate enough that I get to work with some really amazing engineers and teams that have a lot more experience than me, working on missions from the Viking days. So at Lockheed Martin, we're pretty proud to say that we have been involved in every single NASA mission to Mars from the Viking landers in the 1970s, 1960s. So the Viking landers were actually built here in Colorado in our high bay. And since then, we have been involved in every single NASA Mars mission. But Juno, it's a very unique spacecraft that's orbiting Jupiter. And it's the first spacecraft to ever go to our largest planet in the solar system so close. And it's the first spacecraft, too, to have solar power exploring the outer planets, because it's so far away. If you think about it in terms of astronomical units, the Earth is at 1 AU from the sun. Jupiter is a little bit over 5, so it's 5 times further from the sun than Earth is. So out there, typically, the customers would support the spacecraft power with nuclear power. But we had advanced the technology far enough with the efficiency of solar cells that Juno was able to launch on solar power, and it's currently orbiting Jupiter using just the power of the sun, which if you look at it, if you were able to sit at Jupiter, it looks like a little night light because you get 1/25 of the sunlight out there. If we were to use the solar panels here at Earth, they would generate over 14,000 watts, enough to power a home. At Jupiter, we're running the spacecraft with about 500 watts because we get so much less sunlight. So the whole spacecraft runs with about half the power of your microwave or your blender at home. And it's basically trying to understand the origins of the planet. Why go out there? Jupiter is believed to be the first planet that formed, and it's believed to have actually moved close to the sun and moved further away. And it formed first, right? So it has all the early ingredients of the solar system, all the gases, hydrogen. And in fact, it also has water vapor on the atmosphere. So part of the objective of Juno is to understand the origin of Jupiter by understanding the composition, understanding what the core is made out of, because believe it or not, today we still don't know what the core is made out of. Is it a solid or is it something else? Some high pressure liquid? And that will tell us a lot more about the solar system formation and eventually where Earth formed. Some really cool first images. We had never seen the poles of Jupiter from the Earth because of the angle of the ecliptic and the orbit. So Juno is a polar orbiter, so that picture on the left is the first picture ever that we took of the poles of Jupiter. And the scientists are actually still trying to understand it. Some of those storms and basically hurricanes out there are about the size of the continental US. So it's a pretty big planet. You can fit 1,000 planet Earths inside Jupiter. So it's pretty big. So Juno's there orbiting, and we got there in 2016, and we're hopefully going to be there till probably 2023, 2021. And eventually, just like Cassini, the Cassini spacecraft that was orbiting Saturn, we're going to deorbit Juno into Jupiter to destroy it, because we have planetary protection requirements. There's several moons around Jupiter. 4 of them are the large ones. There's one called Europa that NASA's working on another mission. Well, Europa is believed to have more liquid water than all the oceans of Earth combined. So if there's water, there's the possibility of life. So there's a mission in works to go study the moon. And we have to guarantee that Juno is going to go into Jupiter and not contaminate Europa. So before it becomes uncontrollable, we actually have to destroy it to protect and not contaminate the moon. So here's a cool trailer that we built for our orbit insertion maneuver back in 2016.
The scariest thing to me about Juno are the unknowns. So much about the environment that we'll have to withstand is unknown. Nothing's really certain about what's going to happen.
It's a monster. It's unforgiving. It's relentless. It's spinning around so fast, its gravity is like a giant slingshot, slinging rocks, dust, electrons, whole comets. Anything that gets close to it becomes its weapon. It just so happens, deep inside this body are the secrets we're after. Secrets about our early solar system.
It's the biggest and baddest planet in the solar system, and it's got the biggest and baddest radiation and the biggest and baddest magnetic field.
The background radiation that we're exposed to on Earth is about 1/3 of a rad. What we expect to see at Jupiter is about 20 million rad. No spacecraft has ever flown this close to Jupiter, flown this deep into the radiation belts.
So the real trick is, we're gonna go in close, get the data, and get out. And the first time we go in, that's the most dangerous. We call it Jupiter orbit insertion. JOI.
Nothing's really certain about what's going to happen.
Fun fact, they make this really extreme trailer. If you actually think about it, on Friday, before that Monday of orbit insertion, we had sent the entire sequence of commands to the spacecraft. So on that Monday and on Saturday and Sunday, we were just watching because everything had to execute at the right time, and because Jupiter's so far, it takes the signal at the time 50 minutes to get there. So it's not like we're controlling the spacecraft from the ground with the joystick, right? We're not in the loop. So everything was sent on the Friday before, and we were totally hands off. So on that Monday, we were just watching to make sure that main engine lit and that we got into orbit. And everything went perfect, luckily with the help of a bunch of teams of engineers, not only at Lockheed Martin, but at NASA, that does all the interplanetary navigation to get around the planets and all that. So pretty fortunate that we got there. The spacecraft is healthy and safe right now. Eventually, the radiation that they just mentioned on the video will damage it uncontrollable. It affects all the electronics. So eventually, that's why we have to deorbit it into the planet. Fast forward a little bit into Mars. This is our most recent Mars mission, which is actually on the surface that we launched in 2018. And it got there on November of 2016. And I'll show you that entry, descent, and landing sequence, the so-called 7 minutes of terror, that it's really scary. And in fact, because of the time that it takes from Mars, for the signal to get from Mars to here, the spacecraft had already landed, and we had no idea. And again, similar to Juno, everything was sent kind of in a sequence of commands to execute on board the spacecraft at the right time. So InSight, it's the first, it's very similar to another lander that we built called Phoenix back in 2008, finished that mission or so, that landed on the pole of Mars. Phoenix did. InSight differently landed near the equator of Mars. And the whole objective of InSight is to understand Mars, right? Mars, it's sort of very similar to Earth, right? So the whole goal is to understand how the terrestrial planets form, like Venus, Mercury, Mars, right? And it was the first time that NASA had ever deployed a seismometer on the surface of another planet. That seismometer was actually built by the French Space Agency. And we have another instrument on board called the MOLE, or HPQ, that it was the first instrument that's going to drill through the surface of Mars about 5 meters. So deploying a seismometer, first seismometer ever on the surface. The Viking landers actually had a seismometer, but it was on top of the spacecraft. So we had never put a seismometer on the surface of the planet. So you can see an animation there of the seismometer getting placed on the surface. And nobody knew if we were going to detect anything at all, right? Because Mars doesn't have quite the tectonic plates like we have here on Earth. But in fact, we detected the first Marsquakes weeks after placing the instrument. And it's still detecting small quakes. And guess what? Nobody knows where they're coming from quite yet. But that's the point of sending the missions out there, right? To learn what we don't know, and sometimes the scientists even get surprised. We have a little hiccup with that other instrument that's self-hammering itself through the surface. So we're sending commands to move the enclosure around that instrument from here, so everything gets planned well in advance. There's actually a copy of inside of the Jet Propulsion Lab where we sent all the commands with the robotic arms to practice how we need to move things before we actually do anything up there. So we're checking out that instrument right now, and basically what happens is that it has to drill through the surface or self-hammer. The challenge is that the Earth, or the dirt, I should say, at Mars, it's kind of loose, so it needs a little bit more friction. So the scientists are still trying to figure out what they're going to do with the robotic arm to try to help it push itself a little further, but hopefully it will drill or hammer itself through the surface about 5 meters. And behind that little mole, there's a tether, or basically a cable with a lot of temperature sensors. Based on those temperature sensors, the scientists can determine how the heat escapes from inside the planet. And that will tell them a lot more about the core of Mars and the formation of Mars as a whole. Really well stuff. We like to let the scientists kind of handle all that sciencey stuff. Lockheed Martin were responsible for making sure the spacecraft is doing what it's supposed to do. And we're monitoring to make sure that the temperatures and the pressures and all the components are operating as needed. That's our responsibility, to make sure we deliver the spacecraft required that do the mission for NASA. And this is the crazy thing. So we're flying 8 missions total out of here in Colorado in our facility. The 3 NASA orbiter spacecraft orbiting Mars, we control those and build those for our NASA Jet Propulsion Lab and NASA Goddard. Well, they're also supporting this event because inside launch with 2 CubeSats that was able to kind of deliver an image pretty quickly that the Jet Propulsion Lab built. First concepts of CubeSats out to deep space. Luckily, they worked. But if not, Mars Odyssey, that has been up there at Mars for 18 years now, was ready to support. So we got the official signal that the solar arrays had deployed from InSight to our orbiter and back to Earth. So if you're working multiple missions, it can get chaotic because also Mars Reconnaissance Orbiter was copying all the data from the landing to make sure everything had gone well, besides the CubeSats that were doing that too. Mars Reconnaissance Orbiter was flying over and also taking imagery. So a lot of planning goes in years in advance to get all these missions to support each other. And it's basically pretty cool because you're kind of bouncing around between different missions and trying to get everything ready for it. Big events. So fast forward. So yeah, we don't only build cool spacecraft. We're here today because we like to be involved in the community, because wherever we operate, we like to make the community a better place. So there is a ton of community involvement that we do, and we can talk more about it a little later, but we have so many partners, hundreds of thousands of volunteers hours across Lockheed Martin. When we also volunteer at places like Wings Over the Rockies, right? Because it's important for us to bring that new talent and get you excited about what's next. First Robotics, we support the First Robotics competition. Project Lead the Way, Girls Inc. This one's kind of pretty cool because we actually have a group of girls that come spend time at our campus with engineers, and not only engineers, but people from different specialties like the executive leadership team. So they get to experience early on kind of what it takes to work at Lockheed Martin. And you don't necessarily need to be an engineer to work at Lockheed Martin. We have so many different specialties that I'll touch on in a little bit. And Soldiers Angels is another one that's very dear to our heart because a lot of the missions that we do is to support our troops on the ground. So a lot of involvement over the years, and we love it. Fast forward, so why are we here? We actually need you. So we need that next generation of talent and engineers in science, in STEM, right? To help us kind of build those next generation spacecraft. There is so much that we still have to learn about our universe, and not only our universe, but here Earth, right? So we need you. So we started this coolest jobs campaign that somebody apparently thought I was actually cool enough. I don't think so, I just work on cool things. So there's a group of us that have what we call the coolest jobs, and it's a really cool campaign that we're basically going out there and not only supporting events like this, but also recruiting, right? Talking at schools. So if you want one of us, Lockheed engineers, to come talk to our classroom, talk to our community relations people and reach out, we'd love to do that. So there's a group of us working on many different things, and I'll show you a little bit quick video.
So I really love my job.
The coolest job on this planet.
Or any other.
Or at Lockheed Martin Space.
The coolest thing about my job is the product that we send out the door.
One day when all this stuff be on the moon or on Mars, I can look to my children and say, hey, I was a part of that.
We're really allowed to be creative, and it's part of the job to be creative and come up with ways that we think make sense for humans to get to the moon and then beyond and eventually to Mars.
Right now we're operating the InSight lander on the surface of Mars.
We kind of had a moment where we're like, well, we're doing like magic here.
We have arrived.
Touchdown confirmed.
The coolest jobs are in space.
I am a software engineer working at Lockheed Martin Space.
I'm a systems engineer.
I'm a materials engineer at Lockheed Martin Space.
I am a software test engineer.
I'm an RF and systems engineer. Lockheed Martin, your mission is ours.
We're sort of cool. I think we just do cool things. But we're very fortunate with the partners that we have, not only at NASA, but the Air Force, the Navy, the whole defense industry, right? Hopefully you heard, but a lot of us are passionate about what we do because it matters. Take the GOES satellites, NASA missions, you name it. But the cool thing too that I really like working at a large company is that we have an extremely diverse team of different backgrounds, right? I came from Puerto Rico. I wanted to do aerospace. There was no aerospace there, so I had to move to the States. So there's people that come from everywhere with different backgrounds, diverse ideas. It sounds cliche, but we work in really large teams on really complicated things. So we need each other. We're not the smartest person in the room. We have to rely on each other. And it's that diversity of thought that helps us do the really, really complex things that we do at Lockheed Martin for our customers. And that is extremely important. And we have a variety of jobs. You don't necessarily have to be an engineer. So we have, engineering in mechanical, in aerospace, in systems, software, cybersecurity, right? We have to protect our data, computer science, and not only that, so you don't necessarily have to be an engineer, you can work in communications. We have communications folks here today that help us deliver this message back to everybody in the community, right? So that's extremely important. Business, right? At the end of the day, we're a business. We have shareholders, so it's important for us to execute our missions at the right cost, at the right time, right, to deliver to our customers. Business strategy. As we evolved and as the government says, NASA, right, let's send humans back to the moon in 2024, we have to develop the business strategy of how we're going to support our customer, right? Come up with the ideas to help them execute that mission and the nation. Finance, money. We need people that count the money, make sure we're getting paid. Sometimes it's good to get paid. We also have legal teams, right? So there's so much diversity for such a large company that you don't necessarily have to be an engineer. If you don't necessarily like science or math, you can come still work for us and help us support some of these cool missions for NASA. The other cool thing too is that we get to go through continuous learning, and that varies the different forms on how we can do that. There's leadership development programs where you get to rotate around different jobs to get the experience that you need to make yourself a better engineer or a better operations person or a better finance person. So we have this multitude of rotational programs, even in the communications world, that we rotate team members through different opportunities to help them grow and develop that next generation of leaders. And that can start as early as you start your job. You can apply to those programs, and hopefully in like the second year, you get in and you get to go work on a multitude of projects. And we also get to go back to school, right? There's benefits that pay for your advanced education. If you wanted to go get a master's or a PhD, you can continue to learn in Lockheed Martin, going back to school or even on-the-job training. You can just take specialized training, and I'll talk a little bit about some of those specialized trainings. And we have a multitude of benefits. My kind of favorite one is the 980 schedule. So we get every other Friday off, which is actually nice. And that's when you get to do all your other cool stuff outside of work or go hiking in Colorado and take pictures like me. That's probably one of my favorite things of working here, besides all the cool stuff that we do. College internship programs, huge deal for us, right? We like to attract that new talent. Most of our majors in study for particularly engineering and the help that we kind of need are in mechanical and software. One of the good ones in software right now kind of tends to lead more into cybersecurity. So there's a lot of interest in cybersecurity and protecting data. Systems engineering, the people that kind of have the big picture of the really complex systems that we build and get to learn a little bit about everything. We have a lot of systems engineers. And testing. You get to test the product that we build. Be on the floor as we're building it and seeing not only the stuff that you saw on a computer model, but the real thing and the real spacecraft on the floor. You get to test it to make sure that it's going to be able to operate before it gets up there. We test everything. We have a philosophy of test like you fly. So we make sure everything gets tested properly, exposed to the environments of space as close as we can before we ever put it on a rocket and launch it. Electrical engineer. We have a lot of electrical engineer. Juno, solar power spacecraft. There is a few people monitor how much the solar panels are putting out of power, how the batteries are doing, because out there it's extremely important to make sure we have enough power to power all the components on the spacecraft, right? But the really important stuff is the instruments that are collecting the science data. That's why we're there. So there's people that monitor to extreme detail the level of current and voltage on the batteries. And that expertise not only extends to the flying missions, but also the development missions. Next generation of batteries, new technology, developing all that new technology that we need to execute these missions. top schools, they're listed in no special order, but we do have a lot of students and a lot of teammates from University of Colorado, Colorado School of Mines, and a few others that we recruit from. And it's extremely important and a really good opportunity because even in our mission operations area where you're actually flying spacecraft in our teams, we get interns there that get exposed to how does a real system behave in space like that. And they get to work on multiple missions and help us process the data and look at information and understand the health of the spacecraft. One really cool thing that I wish I had the opportunity to participate in is that we're also offering high school internships. I believe Lockheed Martin Space particular, we have about 50-ish or so opportunities in the summer for high school interns that are interested in coming to our campus and spending time with not only engineers, but the team that kind of runs the whole business, right? So it's a 9-week program. You work about 20, 30 hours a week. You have to be 16 years or older, and you have to be local in the near facility. For us, it's here in Watertown, our Deer Creek campus, out in Littleton. And you also get the opportunity to maybe work, still help us out during the years. And it's really cool because you can walk in and help on a mission that is either getting ready to launch or a mission that's already out on another planet or orbiting Earth. You can immediately start working on those missions to help us support that. And we like to make it meaningful work, right? Work that matters, that gives you the experience. Because you don't know, I mean, I didn't know when I was going into college really what kind of specialty I wanted. So to get exposed into the things that you like and you don't like, this is a great opportunity to start early in the different specialties of what we do because it's so big. A lot of training, a lot of on-the-job training and mentoring with different leaders, people with different experiences, right? So you get to learn from others. And there's a lot of support in the background for you. So you have somebody pretty much assigned to you as a high school intern all the time while you're there. And you get to rotate around with people and talk to people and learn from their experiences. Another one that's near and dear to our heart, right, it's we need people, not only the engineers that are designing things, but we need people on the floor, on the clean rooms, that are actually putting the spacecraft together and the components of the spacecraft together. So there's this advanced manufacturing technician apprenticeship program. So you don't need to necessarily have an engineering degree to come work for us. And this is a really cool program because you go through specialized training of what it takes to build these systems, these complex systems. It's paid, and then eventually, if you graduate from that program, you do have the opportunity to come work for us. And we have a lot of technicians, right, because we build really complicated systems. So we need the help, right? We need that experience and the specialty of helping us putting things together. And you go through industry certifications if you want to, that kind of make you a better technician, better engineer through different jobs and different missions. There is an information session coming up on July 25th if you're interested in that. If not, come talk to us and we can get you to the right folks. And there's the location, but if you don't remember any of this, you can always go to our Lockheed Martin Jobs website. There you find a lot of these opportunities, such as the high school internships that I was telling you about, or the college, or full-time jobs. Software computers are doing mostly everything these days. So a lot of data that we manage through these systems, a lot of interactions between these systems. So we need that talent of software engineers, computer science majors to help us control the systems, right? Think about Juno. Juno is super far away, so there's no way we can be controlling it from the ground. So the spacecraft has to be smart enough to protect itself. So there's a lot of software layers, fault protection on board, where it autonomously does things for us in case there's a problem on board. So a lot of those software interactions are extremely complicated, so that's why we need that new talent. But also cybersecurity and network operations, how we get the data. We actually command these spacecraft from Lockheed Martin here in Colorado. But that data goes through an extreme layer of networks through the Jet Propulsion Lab that manages the deep space network, which are antennas around the globe, around the Earth, in Spain, in Australia, and in California. So there's a lot of data and network operations management and ground infrastructure that is needed to support these missions. So we need engineers that know those systems in different sort of backgrounds. We do have a lot of on-the-job training for these programs, and obviously that gets you through additional specialized training that helps you get a full-time position eventually with Lockheed Martin. that is all I had for today, which is actually good because I wanted to see if you guys had questions.